Alrighty, hello there. My name is James, and let's go ahead and reduce some rational expressions, shall we? So what do we have over here? It says answer two questions about the following rational expression, and we have an expression right over here, right? And what are the questions asking, right? It's saying what is an equivalent expression in lowest terms, right? Keyword lowest terms. What in the world does this mean? Well, we're just gonna simplify it, okay? And just get this jargon right over here and make it just nice and simple, okay? Easy to understand. Now, how are we gonna do this? Well, let's separate the numerator and the denominator separately, right? And just look at it one at a time. So I'm gonna go like to the side over here, right? Actually, maybe I'll just do it right here. We have x squared minus 4x plus 4. Now, when I look at this, there's one thing that comes in mind, right? And you may have learned this in school. Hopefully your teacher taught you this. But there's a neat little trick, okay? It's called factoring, okay? Now, what you can do if your expression looks like this, right? When you have three terms, what you can do is look at your constant right over here, right? This is your constant. And see what two numbers multiply to it, but add to this term over here. I know that sounds kind of complicated, but let me show you how it's done. All right. So I'm thinking 2 and 2, right? Two numbers, right? 2 plus 2 is 4. 2 times 2 is 4. That's great and all, but we have a negative 4, right? So what comes in mind is negative 2 and negative 2. Negative 2 times negative 2 is 4. Negative 2 minus negative 2, or I mean negative 2 plus negative 2 is negative 4. So this works. So how are we going to write it? Well, I'm going to go ahead and put an equal sign over here, and we're going to do x minus 2 times what? X minus 2. Just like that. And we have factored this expression. So now it looks a little bit easier, right? A little bit maybe easier to just digest in your head what exactly is going on. In fact, another way you could write this is just putting a little square symbol right there, right? Now let's go ahead and do the denominator, right? So what do we have in our denominator? We have x squared. Actually, do I need to write it? I think you guys can just see right over here. What two numbers multiply to negative 14? Should I change my color? Yeah, why not? But add to 5. Okay? So what are we gonna do? Well, what's the first thing that comes in mind? For me, 3 and 2, right? 3 plus 2 is 5, but 3 times 2 is 6. So that's not gonna work very well. We can also do 5, 7, and 2, right? 7 and negative 2. Actually, that actually works. Because 7 times negative 2 equals what? Negative 14. And what is 7 minus 2? That is 5. So that is very good. These two numbers look like they work. And what are we doing right now? It's called factoring, right? So that's pretty good. So let's go ahead and write it in the form like we wrote it over here, right? So we're going to do x minus 2. Whoops. Plus 7. My bad. I was concentrating on the wrong thing. Because what are we looking at? We're going to be looking at this and this, right? These are the two numbers that we came to a conclusion about, right? 7 and negative 2. X plus 7 and x minus 2, right? And look what we get, right? I know it's a little bit lopsided, but if you can visualize it, we have x minus 2 squared over our denominator, right? And as you can see, we have the same thing on the numerator and the denominator. How cool is that? So let's go ahead, delete it. Boom and boom. And let's go ahead and rewrite it, right? So we still have an x minus 2 on the top, unfortunately, because there's two of them, right? We're multiplying them together. Now one of them's gone. And all that's left is the x plus 7. Not bad at all. So what is the answer to number 1? Let's go ahead, write it down. It is x minus 2 over what? X plus 7. Good. We can do a little box around that. Sweet. And it's asking what values of x must we include from the domains of the expressions. Well, if you didn't know, having a denominator of 0 is a really bad idea, right? Because anything divided by 0, for example, 3 divided by 0 equals what? How's that even possible, right? That just doesn't even make sense. So let's go ahead and look at our original expression over here and see how the denominator can go to 0, right? What ways can it go to 0? Let's go ahead, maybe change the color. Let's go ahead and write our denominator, right? So we have x squared plus 5x, and we're going to turn it into an equation, right? Meaning it's going to have an equal sign somewhere. What are we going to set it to? Set it equal to? 0, right? Because when the denominator equals 0, you just can't have a point there, right? It just doesn't make sense. Okay, in math, dividing by 0, bad idea. So how are we going to do this, right? Well, actually, you know what? Let's look back over here at our denominator over here. Let's go ahead factor it, actually. We have x plus 7, right? We already did this. And let's set this equal to 0. Now this actually becomes much easier to check, right? Because all we have to focus on is one term at a time, right? Because anything times 0 equals 0. So let's look at this over here. X plus 7 equals 0. So if x equals negative 7, then the whole thing will equal 0. So that is one of our answers, right? And the same thing with this, right? We have a negative 2. So in order to cancel out, we're going to have a 2. So x equals 2. And these are the two x values in which we cannot, just this expression is just not going to work. There's no value for it, right? It's just undefined. So that's very unfortunate, but you know, that's sometimes what must happen. Alrighty, so that is the answer to this problem. Let's go ahead and do another one, shall we? Alrighty, we have another problem, and just like that, we can do the same thing like we did last time in the other problem. We have x squared minus 64, right? Let's go ahead and write it down. X squared minus 64. And this question is also asking the same thing, right? So not too bad. So what two numbers, right, multiply to negative 64 but add to nothing? And why is it adding to nothing? Well, we don't have that term like we did before, right? Remember we had 3 terms, and now the second term is missing, right? So unfortunately, it has to add to 0. Well, what I think of is x minus 8 and x plus 8. Because 8 minus 8, that is 0, and 8 times negative 8 is negative 64. So that is pretty good. What about the denominator, huh? Two numbers that multiply to 64, but to 16. Add to 16, right? That should be pretty easy. That's just going to be 8 and 8, right? So let's go ahead, rewrite it. Rewrite it all over again. X plus 8 over, x plus 8, x plus 8. And as usual, there's going to be a thing we can cross out. And we can rewrite our expression, right? Not bad at all. So we got x minus 8 and x plus 8. Great. Not too bad at all. Now let's go ahead, take a look and see how, when the denominator equals 0, right? So we have x plus 8 and x plus 8 again. So unfortunately for both terms, right? So let's set this equal to 0, just the denominator. They're both the same number, you know, positive 8. So the only number that's gonna cancel it out is negative 8. So it's gonna be x equals negative 8. And that is in fact the only number where the denominator will equal 0. All right, not bad. That's another problem done. Let's go ahead and do another one. Alrighty, we have another problem. Can you believe it? Let's go ahead and do the same thing again, right? We're gonna look, separate the numerator and the denominator, and we're gonna check the two numbers that multiply and add to these two numbers, right? So two numbers that multiply to 16, right? I'm thinking 4 and 4. And luckily, it looks like it might actually work, right? If we do negative 4 and negative 4. So we're gonna do x minus 4 times what? Another x minus 4, which we can just say squared, right? Because negative 4 times negative 4 is 16. Negative 4 minus 4 is indeed negative 8. And let's go ahead and do that. For this one, what we can do, you know, we can't use the regular methods like we did with the numerator, right? But we can just factor out the 3, right? So do something like that. And 12 divided by 3, that is 4. So we just have, let's see, yeah, just 3 x minus 4. Not bad. This cancels out. And what do we get? Well, we still have x minus 4. But that x minus 4 is going to be met with a 3. Cool. So what is an equivalent expression in the lowest terms? X minus 4 over 3. Great. And now what about when the denominator equals 0, right? So when it's, I know I probably should have said this earlier, but when it says what values of x must we exclude, it's just really asking for the denominator, right? Now our denominator is just some like linear equation, right? Linear expression. So it's really kind of simple. There's nothing like too crazy about it. And when is it going to be undefined, right? Let's go ahead, set it equal to 0. Actually, let's write it over here. X minus 4 equals 0. Well, the first thing that pops in my head is 4, right? Because 4 minus 4 is 0, and anything times 0 is 0. And it looks like that is indeed the only one. X equals 4 will make our denominator 0, and therefore it's undefined. Not very good. Alrighty, let's go ahead and do one more problemo. Alright, this is going to be our final problem. Hopefully I'm helping you guys understand everything. Let's go ahead, do what we did before, right? For me, I look straight at the constant, right? What happened to my brush? I look straight to the constant, right? I don't know for me, but that's like the first thing I look at, this little doohickey right here. Two numbers that multiply to this, right? And when I look at this, the b term, right? So one way at school, they'll show you how to do this, right? They'll say like, they'll write it like this: ax squared plus bx plus c, right? That's kind of like one way to look at it in a more generic fashion. Yeah. Hopefully your teacher showed you that. But that is not the problem. So yeah, I'm thinking, yeah, -5 and 3. Let's go ahead and write it down. X minus 5 and x plus 3. Okay, not bad. And let's double check, right? Negative 5 plus 3, that's still negative 2. And then when you multiply them, that is negative 15. Good. Now, what about this? This looks kind of iffy, right? Well, two numbers that multiply to negative 9, but add to 0, right? Because we don't have our b value like I showed in that example, right? So let's go ahead, write it down. It's going to be x minus 3 and x plus 3. All right. So when everything's being multiplied, you can just bam and rewrite it, right? So x minus 5. What do we have left? X minus 3. All right. So what is an equivalent expression in lowest terms? It's gonna be this. And what values of x must we exclude from the domains of the expression, right? Fancy word, you know, math likes to use a lot of fancy words, and that's fine, you know. Well, if you looky here, it's actually gonna be a little more exciting. There might actually be two values. Equals 0. Now all we have to do is just look at each of these separately and set them equal to 0, right? You probably already figured it out. But it's gonna be x equals 3 and x equals negative 3, right? So those are the two values in which we have no value at all, right? It's gonna be undefined and it's gonna be a big boo-boo. Alrighty, so hopefully these 4 problems were helpful, you know. Please leave a like, subscribe, and I'll see you in the next video. Bye-bye.